Welcome to the code review section of use case 10. As you can see, I've opened up Visual Studio Code with use case number 10. There is a project by name Docker Compose Spring Boot, which we are going to work out our examples on. If you expand this project, you will see there are two sub-projects. They basically are Java projects. The first one is called Pictolearn Dispatcher, which is nothing but the router. And then there's another project called Pictolearn Web, which is nothing but our web container, similar to what we had in the previous use case. No changes. And then we have the Docker Compose, and also we have the scripts.txt. So what I'm going to do is I'm going to open up scripts.txt and Docker Compose, and also the Docker files from each of these projects, just to give you an overview. So let's take a look at the Docker Compose.yaml. As you can see, this is using version 3.1, which is currently the latest version. As versions change, the impacts are usually minor, so I'm not going to update the lecture for minor changes. Services defines a set of microservices. We have the first microservice as MySQL. As you can see, we've specified the image to be downloaded as MySQL, and we've specified a port. The 8888 is the port available to the host machine. 3306 is the host available inside the container. Host name is MySQL. We've defined two environment variables just to start up MySQL. The second section talks about the web container or the web microservice. If you look at the web microservice, it's the same as what we had before, except for the fact that we've commented out the port. And the reason we've commented out the port is because when we want to scale up the Docker containers, Docker will automatically allocate a port, as I've mentioned here. And then links is used by the code to make a request to MySQL. Dispatcher, on the other hand, is microservice 2. It's a router which will send the request to a specific web container. And then we've specified a port here so that we can connect to the router and make the request. As you're aware, the router is just a dispatcher, meaning it'll try to see when the web containers scale up as to which web container is alive, and then it will make a request to that web container randomly. So this is pretty basic. As I said, it depends. Dispatcher depends on the web service to be up, and the web depends on the MySQL service to be up. So that is as far as Docker Compose. The next thing we're going to look at is Pictolearn Web and Pictolearn Dispatcher. What I'm going to do firstly is I'm just going to import them as existing Maven projects. So just go ahead, click Next, copy the path, and then you can do the same thing with Pictolearn Web. And as long as you have the Docker plugin installed in Eclipse, you should be able to view the Docker file. So let's take a look at the Pictolearn Web. It's pretty much the same as what we had in the previous use case. Note that this uses Ubuntu JDK 8, which we built as a part of use case number 8. And then let's go to Pictolearn Dispatcher. So no changes as far as Pictolearn Web is concerned. It goes by the same code base as what we saw in the previous use case, where you have a user controller. It has three RESTful methods. One is delete, list, and add. And it's just going to add a user, list a user, or delete a user based on the user ID. It's using Hibernate, and the Hibernate properties are injected via application.properties. As you can see, I've just changed this to say update. In case you have the previous use case running, we don't want to interfere with it. I've just changed it to update. And the second thing to note is the host name here, which is MySQL. And this host name is derived from our Docker Compose.yaml, which is this particular section here. So just bear that in mind. Apart from that, everything else looks the same. The model is just a specific user class. It's got an ID, email, and name. So no changes to this particular project, same as the previous one, except that it's going to be named differently from a Maven perspective, wherein we've introduced the name as Pictolearn-web instead of what you saw in the previous use case. So going to the more specific version of the dispatcher, as you can see, this is the version which we obtained from Tomcat 8 JDK 8 on use case number 5. So if you go back to use case number 5, You would have seen Tomcat 8 JDK 8. Feel free to play with this. It necessarily need not be pick to learn. And then the maintainer is as is. I've just installed lsoff to basically find out if to try to debug if one of the web containers is running within the machine. This setup is basically explaining how I set the Tomcat path. I'm trying to expose 8080 and 8009, which is the AGP connector, the work directory, which you're probably familiar with from the previous lectures. I'm trying to add this particular project as is to this particular path in the container. I'm making a directory for the logs. There is a possibility that the logs may not print because Spring Boot keeps changing the logging framework. I've tried my best to print the logs in case it does not work. Since Spring Boot is not the criteria for this course, I recommend that you try to play around with it. And then I'm just copying the directory as is, and I'm doing maven clean package. And then I'm copying the var over from the target directory inside the container to the Tomcat directory. All right. So, and then I'm just starting up Tomcat, plain vanilla Docker file. The first thing to note in the pick-to-learn dispatcher project is the web.xml. As you can see, the web.xml consists of a filter, and anything which is going to be called as far as the URL pattern is going to go through this particular filter. So I've just added this filter as a starting point to start debugging to make sure that the requests are coming in. Now that said, let's go take a look at the most important section of this project, which is the proxy servlet. The proxy servlet acts just as a reverse proxy. For those of you who have worked on Apache or Nginx, you would know that all of these servers not just load balance but also act as a reverse proxy. Now what I mean by a reverse proxy is whenever you do a GET request or a POST request, the request headers, the cookies, and the body is forwarded to a backend system as is. So as you can see, anything which intercepts or has proxy servlet in the URI is going to get forwarded to this servlet. It's got a do get and a do post method, and all this do get or do post do, which is kind of identical, is it just gets the request headers and passes it on to a backend system. That's the long story short. So I'm just going to go over the do get piece of it. The do post piece is very similar, just that it's a post request and it's got a request body, and all it's going to do is it's going to pass it to the backend system as is. Now, there are two things to note here. The first thing is I want to be able to make sure that anything which has proxy servlet has a URI, and I need to pass it to the same URI in the pick-to-learn web server in the RESTful service. So if you look at user controller, it's got a delete, it's got a list, and it's got an add. So when I call this servlet with list, add, or delete, this particular servlet should randomly pick up one of the web containers and invoke those particular URLs. So long story short, just to exemplify this in a better manner, if you see in the past use cases, we had list users, add user, and delete user. One thing which is common among these three is if you see the host name here, it says /list, /add, and /delete. So when we are going to go through a dispatcher, we're going to use the Docker machine name on which this is going to run. The port is 1111, which comes in from the Docker file of Docker compose YAML. For dispatcher, it's 1111. So remember, we're going to call the dispatcher and not the web container directly. And then you have the context name, which is pick-to-learn dispatcher, which basically comes in from this particular value. Or if you look at the pom.xml, I actually give it a final name of pick-to-learn-dispatcher, as you can see here in this particular section. And then what this is going to do is when you call, for example, add, it's just going to say /add. So what I'm going to do is my goal is to call one of the web containers running, since we are going to be scaling web containers up and down. So I'm just going to be calling one of these so that this maps to this particular servlet. So all this reverse proxy is doing is it's basically taking the request headers and the body as is and routing to a container which is up and running. All right. So I highly recommend going through this particular source code. Two things to remember is whenever the response request is made, the headers and the body have to be passed to the backend system. And when the response is made from the backend system, the header and the body should be passed as is to the client without much modification. All right. So for just three things to specify here. One is I get the path. When I say the path basically has to be /list. So what I do is I get the URI and then negate this one, and then this becomes /add. So this is the URL I have to call. I have to call the web container directly. So that is this piece of code. If the path is empty, it's going to say invalid get call. It's going to pick up a random IP address. Now this is an important method to look into. Basically what I do is I go and look at or query all the host names which have web as the name. Now this web is coming in from this particular section where the host name is web. As you can see, if we have 3 containers, web containers running, all of them will have web as the host name, and they'll be mapped to different IP addresses inside the Docker machine. And I'm just going to get one of those IPs randomly and then make a call. So if you go back to the get use case, I get a random IP address. If IP address is null, I return error. If IP address exists, I'm just going to call 8080, which is the port which Spring Boot runs on by default, and then I'm just going to use the Java Net APIs to make a get call. Now remember that I'm adding a header on the way back in the response, and once I get back the response, I process the response and send it back to the client as is. So this is a high-level overview of the proxy servlet. Again, this is not a Java course. I highly recommend going through this particular router. It's not rocket science. It's just a reverse proxy, and all it does is pass request headers and body as is in case of a post, and request headers as is in case of a get to a backend system, gets the response back and passes it on to the client as is. Just that it picks up a random port. And the goal here is to let you know that when you scale, you will need to devise something like this, which can pick up a random port. Typically it's done in Golang or using Nginx or Nginx with Lua or Apache or with sub requests or some kind of modules which can give you the IP address. So you'll have to do some kind of scripting. The DockerCon, they showed this with Golang, but I did it with Java. So the choice is up to you on how you want to do this router. So let's go take a look at a working sample.